Let us go for ionic equilibrium. In the ionic equilibrium, first we will see acids and bases. In the acids and bases, first theory is called Arrhenius theory. What Arrhenius theory says regarding acids and bases we will see. As per Arrhenius theory, which is acid means which substance on dissolving in water gives H plus, that substance is called acid. So, as per Arrhenius theory, which is acid means we are taking some substance that we have to dissolve in water, that should dissociate in water, and it should give H plus. Then that is called acid. Okay, so therefore we can say acid in the sense that will give H plus in the solution, in the aqueous solution. Okay, example we can say HCl. HCl dissolves in water and gives a and dissociates and gives H plus aqueous and Cl minus aqueous. Since HCl aqueous gives H plus ions, therefore HCl is an acid. Okay, this acid is called a Arrhenius acid, we can say. Then we will take acetic acid. Acetic acid we can write like this. We are writing acetic acid like this. This we will dissolve in water. It undergoes ionization. It undergoes ionization in the sense this bond is migrating to oxygen. Why? Because oxygen is more electronegative than hydrogen. Therefore, this bond is migrating to oxygen. So we are getting a CH3, COO minus and H plus. CH3CO minus goes to water, aqueous. H plus also goes to aqueous. So this acetic acid dissolves in water and dissociates and gives H plus. Therefore, this acetic acid we can say as a acid. We can say this we can say acid. Okay. Now let us take a HCl. HCl we will take how much means 1 mole of HCl gas we will take. 1 mole of HCl gas. Let us pass this 1 mole of HCl gas into 1 liter of water. Let us pass 1 mole of HCl gas into 1 liter of water. We are getting 1 molar aqueous solution of HCl. Okay. Now, in this solution, what is the concentration of H plus? We will see. Concentration of H plus is X molar. We will take. Concentration of H plus is X molar. We are taking. Okay. Because HCl is dissociating to give H plus ions. The concentration of H plus ions in the solution is X molar. That in the same way, let us prepare 1 molar aqueous solution of acetic acid. 1 molar aqueous solution of acetic acid we are preparing. This acetic acid is dissociating and giving H plus. How much in the sense Y molar it is giving. Acetic acid dissociates in aqueous solution to give Y molar H plus. Now let us compare this X molar and Y molar. Let us compare. X is much greater than Y. X is much greater than Y. That means this HCl ionizes to large extent. Therefore, H plus concentration is much high. Acetic acid ionizes to less extent. Therefore, H plus concentration is very less. Okay. So here we can say HCl ionizes to large extent. Therefore, HCl is called strong acid. Acetic acid dissociates to weak extent, less extent. Therefore, acetic acid is called a weak acid, we can say. So, in this way, Arrhenius theory says acid and classifies the acid into strong acid and weak acid like this. What about base? Base in the sense that has to give OH minus in water. Okay, now we will take sodium hydroxide solid. Sodium hydroxide solid we are taking. Let us dissolve the sodium hydroxide solid in water. Therefore, we are getting sodium hydroxide aqueous solution. This ionizes to give ions. What are the ions in the sense? Na plus aqueous and OH minus aqueous. Now, Sodium comes under first group, alkali metals. Alkali metals always shows plus one charge in the compounds. So on dissolving in water, alkali metal ion gets detached from the compound and goes to aqueous solution. So sodium hydroxide we are dissolving in water, sodium getting detached from sodium hydroxide as Na plus and goes to aqueous solution. Okay, now Na plus aqueous is there, remaining is what in the sense OH minus aqueous. Okay, now this sodium hydroxide dissolves in water, then dissociates to give OH minus ion in water. Therefore sodium hydroxide is a base. Next we will take ammonia gas. Will take this ammonia gas will pass into water. It will combine with water and become ammonium hydroxide. It reacts with water and becomes ammonium hydroxide. This ammonium hydroxide dissociates in water to give NH4 plus aqueous and OH minus aqueous. So ammonia gives OH minus in aqueous solution. Therefore ammonia is a base as per Arrhenius theory. Now sodium hydroxide dissociates to larger extent and gives larger concentration of OH minus ion. Therefore sodium hydroxide is strong base. Ammonia dissociates to lesser extent and gives a lesser concentration of OH minus. Therefore ammonium hydroxide is a weak base. So as per Arrhenius theory, strong base in the sense that base dissociates to larger extent in the aqueous solution. Weak base in the sense that base dissociates to lesser extent in the aqueous solution. Okay, so on. So this is said by Arrhenius theory. Okay, next theory we will take. Why we have to go for next theory? Now we are taking some substance. If it is not dissolving in water, then can we how to say whether it is acid or base? Can we say that all the substances dissolves in water? No. Of course, most of the substances dissolves in water, but we can say all the substances dissolve in water. We cannot say. Sir, okay. Then Arrhenius theory says the substance is acid if it gives H plus to water. Others, what about other solvents? That means this Arrhenius theory is limited to certain thing. Only solvent is water. Arrhenius theory is limited to only solvent is water. Therefore, this Arrhenius theory is having limitation. What in the sense it confines definition of acid and base to the solvent water alone. Therefore, another theory is introduced. That theory is elaborately substituted for elaborately given for other solvents also. Okay, what is that other theory? We will see. Now we are taking another theory that is called Lowry-Bronsted theory. Lowry-Bronsted theory. Okay, we are taking Lowry-Bronsted theory. As per Lowry-Bronsted theory, acid means H plus donor. H plus donor. Acid means H plus donor. Here in this theory, the solvent is not mentioned as water. Anything it can be. If substance is donating H plus, then that substance is called acid. If substance is accepting H plus, then that substance is called base. So as per Lowry-Bronsted theory, the substance which donates H plus is called acid. One which can donate H plus, one which can accept H plus is called base. It is a Lowry-Bronsted theory. Sir, now we will take HCl. Let us dissolve HCl in water. What we will get, we will see. We will get what in the sense one is called H3O plus, another one is called Cl minus. Okay, so and so we are getting. How we are getting this one, that we will see. Now we will take here water. We will take that water. We are writing like this. This oxygen is having 2 lone pairs. HCl we are writing like this. Cl is having 3 lone pairs. Now This oxygen is contributing lone pair to H. This bond is migrating. Therefore, we are getting this oxygen, two hydrogens, another hydrogen with a dative bond. Here, lone pair will be there. Then this Cl. Now Cl already is having three lone pairs. Now this Cl is taking this bond pair completely, therefore minus charge, and this hydrogen loses this bond pair, therefore plus charge. Then we can write this dative bond, we will write it as normal covalent bond, for which while we have to give formal charges. So what is the formal charge we have to give, that we will see. So now three hydrogens we have written, that lone pair we will write. Now this dative bond we have written as a normal covalent bond. This hydrogen is acceptor. For acceptor we have to give -1 charge, already +1 charge is there, therefore net is 0. For oxygen is a donor. For donor we have to give +1 charge. So for oxygen +1 is the formal charge. This H3O plus is called a hydronium ion. H3O plus name we can call it as hydronium ion. Now this HCl on dissolving in water gives hydronium ion and Cl minus ion. This HCl gives H plus to water, therefore HCl is acid. Water takes H plus from HCl and becomes H3O plus, therefore water is base. Water we can call it as a base, we can call. Okay, next we will see. Next one, we will take HCl. We will dissolve HCl in acetic acid. We are dissolving HCl in acetic acid. So what we are getting in the sense, CH3, COO, H2 plus and Cl minus. How we are getting this one, that we will see. Now we will write acetic acid, we will write CH3, C11O, OH. This O is having 2 lone pairs. HCl we will write like this. Cl is having 3 lone pairs. Now this oxygen is contributing lone pair. This bond pair is shifting towards Cl. So what happens, we will see. This CH3, C11O, this O, here lone pair, here dative bond, H is there. This Cl will write separately. Now Cl will have 4 lone pairs. Cl will have 4 lone pairs because bond pair is shifting towards Cl as bond lone pair. Cl is getting negative charge, hydrogen is getting positive charge. Next, we will write this dative bond as a normal covalent bond. Therefore, CH3, C11O, OH. Hydrogen is acceptor. Hydrogen is acceptor means -1 you give it, already +1 is there, therefore becomes 0. For oxygen we have to give +1. Okay, this is only we have written as CH3, COO, H2 plus like this, and this Cl minus we have written. Now HCl is donating H plus to acetic acid, therefore HCl is an acid. Acetic acid takes H plus from HCl, therefore it is a base. Okay, now understand that here acetic acid is a base. Okay, because base means what, that will accept H plus. Acid means what, that will donate H plus. Okay, next we will take. Next, we are taking a HCl. We are taking HCl and we are taking benzene. Okay. What happens means nothing happens. Nothing happens here. Nothing happens. Nothing happens in the sense HCl is not donating H plus. Benzene is not taking H plus. Therefore, HCl is acid or base. Nothing. We cannot say anything. Whether HCl is acid means acid? No. Whether HCl is a base? No. What we can say? We cannot say anything. Why? Because HCl is not donating H plus, benzene is not accepting H plus. If H plus transfer is there, then only we have to say acid and base. If H plus transfer is not there, then we cannot say whether it is acid or base. Here nothing is donating H plus, nothing is taking H plus, so nothing is acid, nothing is base. So we cannot say HCl is an acid here. Okay, so whether the given substance is acid or not, how to say as per Lowry-Bronsted theory means, if the given substance donates H plus to another substance and another substance taking H plus, then only the given substance we have to call it as donating H plus, and we have to say H acid. Okay, so that now whether the substance is acid or not, how to say in the sense, now suppose we are taking substance A, whether it is acid or base, how to say in the sense, you mix this substance with another substance, suppose B, not only another substance, to how many substances you want you can mix it. Okay, then if it is donating H plus to this and it is accepting that, then it is acid, it is base. If it is neither donating nor accepting, it is also neither donating nor accepting, then it is not acid, it is not base. We cannot say whether it is acid or base. Now we can say HCl is neither acid nor base in benzene because they are not mixing with each other. Why they are not mixing with each other? Because HCl is a polar covalent bond. HCl is having polar covalent bond. Benzene is non-polar solvent. For benzene, dipole moment is how much in the sense? 0. For benzene, net dipole moment is 0. Benzene is a non-polar solvent. HCl is a polar bond. HCl is having polar covalent bond. HCl is called a dipole. HCl is a dipolar molecule. So it is having dipole moment. HCl is having dipolar molecule. It is having dipole moment, but benzene nothing. Therefore, they are not mixing with each other. Nothing happens between them. Therefore, we cannot say HCl is acid or not. Okay, sir. So as per Lowry-Bronsted theory, if H plus is donated, then we can call it as acid. Otherwise, no. Okay. Next step. So what is base also we said. Next we will see in this one. Now we will take HCl. Let us dissolve HCl in water. Then what will happen in the sense? This aqueous solution will get equilibrium. We are dissolving HCl in water. We are getting aqueous solution. In the aqueous solution, what will be there in the sense? Equilibrium will be there. In that equilibrium, what and all will be there means so and so will be there. So and so will be there. Okay. So we are dissolving HCl in water. We are getting equilibrium. In that equilibrium, which and all will be there means undissociated HCl aqueous water molecules, hydronium ion H3O plus and Cl minus ions. These and all will be there in the aqueous solution of HCl. Okay, sir. So aqueous solution of HCl is having what and all, that we got an idea. Now let us say that this HCl becomes Cl minus by donating H plus to water. Therefore, HCl is an acid as per forward. Okay. Now backward we will see. Cl minus is becoming HCl as per backward by taking H plus from hydronium ion. Therefore, Cl minus is a base. Cl minus takes H plus from hydronium ion and gives HCl. Therefore, Cl minus is a base. Now we will take HCl and Cl minus. HCl and Cl minus we will take. HCl is an acid. In the HCl, if H is in the HCl, if H plus leaves, what is the residual part? Cl minus. That residual part we can call it as its conjugate. HCl will take, it is an acid. If H plus leaves, then residual part is Cl minus. The residual part we have to call it. It is its conjugate. We have to say it's a conjugate. This conjugate is acting as what? As per this equilibrium is a base. Therefore, it is conjugate base. So for acid, what is its conjugate means? That is base. So for acid, how to say conjugate base in the sense, remove one H plus from the acid, then remaining is called conjugate base. Okay. Now we can say that so this HCl and Cl minus are conjugate acid base pairs, we can say. So conjugate acid base pairs. Conjugate acid base pair is what in the sense? HCl Cl minus. Next we will take H2O. H2O is taking H plus from HCl and becomes H3O plus. Therefore, H2O is base. This H3O plus is donating H plus to Cl minus and becomes water as per backward. Therefore, H3O plus is acid. Now, H2O and H3O plus are what in the sense conjugate acid base pair we can say. H2O and H3O plus are what in the sense conjugate acid base pair we can say. So, as per Lowry-Bronsted theory, every acid will have its conjugate base. What is the difference between conjugate acid and base means 1 H plus. 1 H plus is the difference. Okay. Conjugate acid base pair differ by 1 H plus ion. Now see, HCl Cl minus is conjugate acid base pair. Between them, what is the difference means 1 H plus. H2O and H3O plus is an example for conjugate acid base pair. What is the difference means 1 H plus. 1 H plus is the difference. Okay. So conjugate acid base pair means that differ by 1 H plus, like that we can say. Okay. Next we will say that relative strength of acids and bases. Relative strength of acids and its conjugate bases. That we will say. Relative strength we will say now. Okay. To say the relative strength, let me take the known acids and all we will take. Certain acids we will take. Okay. We will take one acid is called perchloric acid. Perchloric acid formula is what in the sense HClO4. HClO4 is the perchloric acid. Next, hydrogen iodide, hydroiodic acid. Next, hydrobromic acid. Next, sulfuric acid. Next, hydrochloric acid. Next, nitric acid I will take. Okay, I have taken like this. Now, first what I have taken in the sense perchloric acid I am taking. Perchloric acid formula is what in the sense HClO4. That HClO4 will take. Let us dissolve HClO4 in water. What we are getting in the sense H3O plus aqueous and ClO4 minus aqueous. This HClO4 is called perchloric acid. This we are dissolving in water. Then it is giving what in the sense H3O plus hydronium ion and the remaining is ClO4 minus, that is called perchlorate. The ClO4 minus name is called perchlorate, we can say. Perchlorate ion. Okay. What is the structure of HClO4 and what is the structure of perchlorate ion, that we will see. Okay. Now in this one we will take Cl. In the perchloric acid we will take Cl. And 4 oxygens are there, those 4 oxygens we will write. In the perchloric acid, 4 oxygens are there, those 4 oxygens we have written, and we are writing even hydrogen we are writing. Okay. Now see that hydrogen will make single bond. Oxygen can make double bond. Oxygen can make double bond. Otherwise, oxygen can make 2 single bonds. Oxygen can make 2 single bonds, otherwise a double bond. Okay. Now, here OH group is there in this compound. In this compound, OH group is there. This OH group can donate H plus but not OH minus. This molecule can donate H plus to the water but not OH minus to the water. Therefore, it is called oxyacid. Oxyacid means that will have OH group. This OH group hydrogen is having acidic nature. This OH group hydrogen is having acidic nature, we can say. Okay, so now we can say this bond is migrating to oxygen. Therefore, it is donating what in the sense H plus. Now it is donating H plus. Then what is the remaining in the sense Cl double bond O, double bond O, O minus, double bond O. Okay, we are getting like this perchlorate ion we are getting. So this OH group is donating H plus, therefore it is, this compound is called oxyacid. So oxyacid in the sense that compound will have OH group. From that OH group, H plus will be donated to the aqueous solution. Okay, so this perchloric acid is a oxy acid. Okay, now this perchloric acid is donated H plus, we said, therefore what we are getting in the sense perchlorate ion we are getting. Okay, next we'll say that now we will take perchlorate. How much perchloric acid? How much means 1 molar. Concentration is 1 mole. How to prepare 1 molar aqueous solution of perchloric acid? That we'll see. Now we are taking what in the sense standard flask we are taking. We are taking a standard flask we are taking. In the standard flask here mark will be there. And here 1 liter will be engraved. That means it is 1 liter standard flask. Now we have to take 1 mole of perchloric acid. You take and take here 1 mole of perchloric acid you are taking here. Then add water. Then go on add water. Go on add water till the water comes near to this mark. Then the surface of solution, at the surface of solution you see meniscus will be there. In the meniscus, lower meniscus should coincide with this mark. Lower meniscus should coincide with this mark. Then this is called 1 liter solution. Okay, then close this standard flask with cork and shake very well. You will get 1 molar aqueous solution of perchloric acid. So we got 1 molar aqueous solution of perchloric acid. We got it. Okay. This perchloric acid is dissolved in water. Therefore, it is dissociating. How much perchloric acid is dissociating means nearly 1 molar. So how much undissociated perchloric acid is there means almost nil. Now hydronium ion we will see. Hydronium ion concentration is 1 molar. Perchlorate ion concentration is 1 molar here. That means this perchloric acid dissociates completely in aqueous solution. Therefore, initial amount of perchloric acid is 1 molar. Concentration of hydronium ion also 1 molar. Okay, perchloric acid dissociates completely. Therefore, what is the concentration of H plus in the aqueous solution means 1 molar we can say. Okay, now you say that here perchloric acid dissociates completely in aqueous solution or what? Completely in aqueous solution. Therefore, perchloric acid is called strong acid. So, strong acid means that dissociates completely in aqueous solution. Okay, so what is strong acid? That dissociates completely in aqueous solution. That is called strong acid. Okay, so we can call this HClO4 is a strong acid because it dissociates completely in aqueous solution. That means in this case equilibrium lies almost right. In this case equilibrium lies almost right. Now we will take that this strong acid means how to define strong acid. We'll see. This HClO4 is a HClO4 acidic strength we will take. Now acidic strength of H3O plus we will take. Okay, HClO4 is an acid because it is giving H plus. Then as per backward, H3O plus is acid, correct? As per backward, H3O plus is acid. Now acidic strength of H3O plus also we'll see. Acidic strength of H3O plus and HClO4 will compare. Now here equilibrium lies almost right. That means which is having higher acidic strength, H3O plus or HClO4? Which do you say? Equilibrium lies almost right in the sense left, the backward is almost not there, only forward is there. Equilibrium lies almost right in the sense forward took place, backward almost nil. Backward almost nil in the sense which will have higher acidic strength, HClO4 or H3O plus. We can say HClO4 is having higher acidic strength than H3O plus. Then we'll see acidic strength of H2O and acidic strength of HClO4. Here, this HClO4 is donating H plus, H2O is taking H plus, therefore H2O is a base. HClO4 is donating H plus, therefore it is an acid. H2O is taking H plus, therefore it is a base. Therefore, out of HClO4 and H2O, which will have higher acidic strength? HClO4 will have higher acidic strength. Correct? So acidic strength of HClO4 is greater than acidic strength of water. Like that we can say. Therefore, if acid falls under this category, if acidic strength of water is greater than that of hydronium ion, then that acid is called a strong acid. Okay. So which acid we have to call it as strong acid? If that acidic strength is greater than hydronium ion, then we have to call that acid is a strong acid we have to call. Okay. So which and all strong acids we will see. These and all strong acids. We can call these and all strong acids we can say. Okay. So HClO4 to HNO3 we can call strong acids we can say. So what is the how to say whether the given acid is strong acid or not? How to say? If the acidic strength is greater than hydronium ion, then only that acid we can call it as a strong acid. Okay. That acid on dissolving in water will undergo complete dissociation. Okay. So next we will see. Next we will take H3O plus. Next we are taking H3O plus. Okay. Next we will take some more acids. That is HSO4 minus, HF, HNO2. HNO2 is called a nitrous acid, then acetic acid, carbonic acid, hydrogen sulfide, hydrogen cyanide, ammonium ion, water, like this we have taken. Now we will take acetic acid. We will take that acetic acid, let us dissolve in water. So what we will get to that we will see. So now we are taking acetic acid. This acetic acid is an oxy acid. It is having OH group. That OH group donates H plus. Therefore, water takes H plus and becomes hydronium ion. Acetic acid becomes acetate ion. Acetate ion goes to aqueous solution. Hydronium ion goes to aqueous solution. Acetic acid also dissolves. Okay. Here. In the equilibrium, if we see, acetic acid is in dissociated form. Undissociated acetic acid is there in the equilibrium solution. Okay. Hydronium ion is present, acetate ion is present. Everything is present. Now, this equilibrium, what is the position of equilibrium? That we will see. Position of equilibrium, if we see, equilibrium concentrations are comparable. Equilibrium concentrations are comparable. Equilibrium concentrations are comparable means what? We cannot say whether equilibrium lies almost to right. Similarly left. Okay. That means left side we have to consider, right side also we have to consider. But in this case, what we said, equilibrium lies almost right in the sense left side almost not there. Only right side is present in the equilibrium solution. Isn't it? That means if left side not there, then how do we say equilibrium means left side is almost negligible? That is the meaning. Okay. Here we cannot say that left side is negligible or right side is negligible. We cannot say because equilibrium concentrations are comparable. Okay. Now this acetic acid is donating H plus to water and becomes acetate ion. Therefore, acetic acid is an acid. This H3O plus donates H plus to acetate ion and becomes water. Therefore, H3O plus is an acid. Okay. Now, for this case, what is the equilibrium constant means? Equilibrium constant is equal to roughly 10 power minus 5. A is called acid. K is called dissociation constant because acetic acid dissociates to give hydronium ion and acetate ion. Therefore, this equilibrium constant we can call it as acid dissociation constant. Like this we can call. Okay. Now we will see acidic strength of acetic acid and acidic strength of hydronium ion we will see. Okay. Now we are taking in this case acidic strength of acetic acid we will take, and acidic strength of hydronium ion we will take. Now you say which is having higher acidic strength. You say acidic strength of this acetic acid and acidic strength of hydronium ion we are seeing. Equilibrium constant you see 10 power minus 5. So can we say that acetic acid strength, this acidic strength is less, this acidic strength is more, shall we say? Okay. So we can say that acidic strength of hydronium ion is more when compared to acetic acid. Then acidic strength of acetic acid and acidic strength of water we will see. Okay. Now, if you dissolve acetic acid in water, we will get hydronium ion and acetate ion. We are getting a hydronium ion in the sense water takes H plus from acetic acid and becomes hydronium ion. Therefore, water is acting as a base, isn't it? So, water is acting as a base, acetic acid is acting as an acid, means which will have higher acidic strength out of these two? It will have higher acidic strength. It is having lower acidic strength, therefore it is a base. Then how do we say water? We said water we called as a base. Then how do we say it is having acidic strength? Now, whatever the substance you take, that substance is always, suppose you are taking one substance. Can you call that substance is always acid? Never. We have seen HCl. HCl we have passed into HCl gas, we have passed into benzene. What had happened? Nothing happened. In that place, HCl is not an acid. We cannot say whether HCl is acid or base. Therefore, that means whatever the substance you take, that will have acidic nature as well as basic nature, which is dominating with respect to another, as per that will act. Here, for this acidic nature is dominating, therefore it is acting as an acid. For this acidic nature is not dominating, therefore it is acting as a base. Therefore, acidic nature of acetic acid and water, if you see, which is having higher value, in the sense acetic acid will have higher value. Okay. So, if the acidic strength of given substance is lesser than hydronium ion and greater than water, then that substance is called a weak acid, we can say. Okay. So, which is weak acid? If the acidic strength of given substance is less than hydronium ion and greater than water, then that substance is called weak acid. So for weak acid, these are the examples. For weak acid, not only this example, many weak acids are there. Many weak acids are there. We have written some example, we have written a few weak acids we have written. Okay, sir, don't include water in the weak acid. Similarly, don't include hydronium ion in strong acid, otherwise weak acid. Write separately. Hydronium ion is separate here. Okay, and water is separate here. Water is separate here. Okay, then we will take some more. We will take some more acids. We will take some more acids. What in the sense that is NH3, then OH minus, H2, CH4. Like this we will take. Now I will take H2, I will take H2 gas, I will take, I will pass H2 gas into water. Now what I will write in the sense of H3O plus H minus I will write. Like this I have written. That means this H2 I will take like this. It is having one bond. In the hydrogen molecule, one bond is there. Now let me shift the bond like this. Then it will become H plus, it will become H minus. H minus in the sense, H minus in the sense that will have one lone pair. H minus in the sense that will have lone pair. Okay. So in the hydrogen molecule, we have shifted